scale. You're not allowed to do that.
You're going into this camera, right?
We're on this one.
This one?
Yeah.
Oh yeah. Okay, great. I'll turn these internals on. Alright, great.
John, I'm going to focus kind of on this book because it's the
Great.
only one that I've read.
That's great, but that's my actual subject,
Okay.
believe it or not. Yeah, everything else is sort of secondary, really,
All right.
to me anyway.
I mean, would you? Well, it's obviously the Morning Star. It's been called
Morning Star. Yes, that's right. Yes. Yeah.
Yeah, really cool.
I think they certainly there is a star in Masonic ritual. Whether they really how well aware of some of the numbers they would have been, I wonder. I mean, some of it's only just been discovered now, so they couldn't possibly have known some bits of it. Venus's axial rotation period was only discovered in the 1970s when they bounced radar through the clouds.
Right.
So it was only then that they discovered that it was synchronized. And Mercury's was another good example. Mercury's axial rotation wasn't known until quite recently. So a lot of these harmonics it's all being discovered now.
Yeah.
Trouble is you've got a scientific climate now that isn't really conducive to sort of thinking along that way. Although actually it is there in the scientific literature. There's more and more papers pop up about orbital resonances. You didn't hear about orbital resonances massively 20 years ago. Now most papers on extrasolar solar systems that are being discovered talk about orbital resonances and planets being locked into orbital resonances with each other and forming 2-3s or 1-2. But the fact that those are then themselves musical intervals doesn't seem to be discussed very much.
Because it's just crazy, isn't it? It's almost. I mean, that level of. Well, we'll say.
Yeah.
I just can't get over it. I think it's remarkable.
Some of it's some bits of it are really, really interesting. They really are, and thought-provoking.
I've been rolling, so.
Oh, you're rolling anyway.
Yeah.
Okay.
Oh, okay.
Right. Stop talking quietly then.
Yeah. So, and just remember to try and answer with the question.
Absolutely. Form a proper sentence.
Yeah.
I should be able to do that. Okay. Yeah.
All right. So we'll start by asking, how did you get into this, John? This being a rogue astronomer. Can you tell us what it was that piqued your interest?
Yeah. I mean, I wouldn't necessarily say I'm a rogue astronomer, particularly, but I you could describe me as that. I think my journey really starts with crop circles, which is a very strange place for it to start. I was already interested in stone circles a lot, and had visited a lot of stone circles in the UK. Very interested in the work of Alexander Thom, who'd sort of deciphered some of the geometry of stone circles, and I was interested really at a very minor level, but it wasn't something I was spending an enormous amount of time thinking about. And I was writing computer programs and involved with the computer games industry slightly at the time, and I happened to pass a crop circle, and I put my car into the ditch as I went by it, and I'd spent this night with my car stuck, unable to go anywhere, wandering around this crop circle in the middle of the night. Nice night, very beautiful crop circle, and just completely gobsmacked as to what it was. And then I started looking at crop circles and became very interested in why they were so beautiful. And it was really the beauty of them. They seemed to sort of be very, very well proportioned. In the early days, you really just had a couple of rings and outer elements, but there wasn't an obvious aesthetic, but the rings were proportioned very well, very beautifully. It was very sensitively done. If there was an outer circle, it seemed to be a good size, exactly the right distance from the middle. They'd been done very beautifully, and that was the first point I became interested in proportion and geometry, and began to look at the proportioning systems used in the crop circles. And then when I discovered that there were lots of root 2s, Gerald Hawkins was doing pretty much the same work as me at the time, and John Michel. And once it became evident that there were root 2, root 3 proportions in the crop circles, and those were the same proportions that were used in medieval cathedrals and most well-proportioned buildings, even rooms of stately homes. All the principles of proportion and geometry used by architects over the years were being used by whoever or whatever was behind the crop circles. That seems to be very odd. And then there was I wrote a computer program at that point to analyze the geometry of a crop circle. So I could just type in a crop circle into this program as a series of circles and centers and radii, and it would analyze it and spit out the geometry for me, saved me a lot of time and work and ruler and compass work. And then one afternoon I just happened to type in the solar system. I just thought, well, I'll just type in the solar system into this program. It's only a couple, it's not very many circles. I'll just type in the mean orbits of the solar system. It's only 7 or 8 of them. And typed them in, and then came up with some of these really interesting relationships that I thought were kind of, why haven't I seen that in any book anywhere? And then took it up to a professor of, I happened to be staying in a house where there was a professor of astronomy from Glasgow there for the weekend, and showed my work to him, and he happened to be his speciality, funny enough, the Bode's theorem and everything. He sort of encouraged me and said he hadn't seen it either, and I couldn't quite believe that no one had done this before. And then I carried on strictly as an amateur, developing that work, and that's really how I got into it. It was a journey through trying to understand the rules of beauty and applying the rules of beauty to forming a database, if you like, of beautiful relationships which are harmonic or geometric, and then applying the solar system to that database is what I did. Yeah.
And when you talk about the beauty of the circles, were there any specific angles or ratios that you found while you were looking at the circles that were prompted by them, shall we say?
Charlie, you can take one step to your right.
To the right,
Yeah,
like this.
that's great.
There were specific ratios that cropped up again and again and again. The use of the halves and obviously root 2s was common. Root 3s were quite common, but not specifically. The one that was being used again and again and again, much to my surprise, was the golden section. And the golden section is not an easy thing to get your head around, particularly 1 over the golden section squared. So that's 1 to 2.618 was being used a lot. So an example would be if a circle was sized 1, you'd find a grape shot or an outlier at distance 2.618 from the center. That's a proportion defined by where the arms cross on the pentagram. And interestingly, the circle makers had also realized that proportion could also be given by an octagram. So an 8-pointed star defines an incircle. The circle that fits inside an 8-pointed star is the same circle as fits where the arms cross on a pentagram. So the 5 and the 8 talk to one another, is the best way you can say, at that level. And again, I'd never seen that published anywhere, and by that time I was studying geometry and sacred geometry quite hard, and I gone through all the old books that I could. No one had really mentioned it very much, that the five-fold geometry and 8-fold geometry have a dialogue. It was early days for me, and to this day I haven't really seen anyone draw anyone's attention to it on paper or in print. But the circle makers seem to sort of be onto this and be using it creatively. And there were lots of examples from 1990, 1991, 1992 to show that they were doing so intelligently and deliberately. At the same time, I was very interested in that specifically because of the 5-8 relationship between Venus and the Earth, and it just there was just a sort of eerie sense for me at the time of what was going on, and why wasn't anyone aware? Why wasn't anyone aware of this? And at the same time, I was obviously telling myself not to be silly, because who could possibly take this sort of thing very seriously anyway? So one was having to be quite careful what was said and published. And I did publish quite widely, but I didn't actually publish what I was thinking a lot of the time. I just published my results and kept it clear of any interpretations. Yeah.
You're doing great.
Okay.
So going back to what the circles taught you specifically, can you talk a little bit about how they inspired you to kind of crack the squaring of the circle to a closer degree than anyone previously had achieved?
The squaring of the circle. I don't remember that one. Which one was that?
It would be the 4 circles around a larger.
Oh, those ones. That's Alan Brown's work, I think, isn't
Is it?
it? I think so. Yeah.
Oh, okay.
I think it was Alan Brown did the huge study of squared circle stuff on the quintuplets.
Okay.
But the thing I discovered, Alan Brown's work on the squaring of the circles, different ways of squaring a circle in early crop circles with the quintuplets, it is amazing, because he manages to show that the entire corpus of early quintuplets are all different ways of squaring a circle. I mean, and really accurately so, and really creatively so. It's fascinating work. My work was more based on pure geometric relationships, and I did discover something else that really I've used a lot widely since, and I've even discovered it being widely used on the other day as a design principle. No one ever taught it to me, but I do use it to this day as a design principle. Where did I discover it? Oh yeah, on a McDonald's drinking vessel. They had this design with lots of little circles all over it, and there it was. You unwrap it, and it's exactly the same thing. It's basically called an edge alignment, and you take a line and you make elements just touch it, but not pass through or intersect with it. And again, a lot of the early crop circles were using this really, really intelligently, carefully, and well as a design principle. So there's a real difference between when you're onto something on your own, when you're researching something and you're the only one that knows about that. That's a very different period to the period after you've published. The moment you publish, assuming there are, if you want to assume there might be people out there hoaxing crop circles, you can assume that they might be interested in your publication, and they might read it and they might adapt and what they're doing to what you've published. But there's the amount of evidence that I had to back up my theories before I published was considerable. And at that time, there was no one, I hadn't shown it to anyone. And so to this day, I stand good by it, saying that whoever or whatever did them was doing them was really, really well, a really, really fantastic designer. There was a level of design and intelligence of design and a synthesis of really difficult principles in harmony and geometry going on that most people don't even begin to grapple with. You can't just sort of dismiss it and say it was a couple of guys out on a Friday night. I mean, I'm sure there are some crop circles like that, but some of the ones we were looking at in the early days were extremely well thought through and well designed. If they were done by a couple of guys out on a Friday night, what they'd hit on in itself was amazing. So it's a bit like just happening to stumble in on a bar and hear a particularly good musical set by a couple of non-musicians that just happened to be in really good form that evening. And it could be that was what was going on as well. So one doesn't really know.
You kind of led me into hoaxes.
Yeah.
What are the chances that hoaxes, locals, would have this kind of knowledge of geometry, would be able to inform us or you, someone who's a professional, about these kind of things? Doesn't it seem a little, against the odds, improbable that a hoaxer would be the one to bring these revelations to us?
I just don't know about that. I think it's impossible to say, really, to talk about the origin of something when you just don't know where it's come from. There are people that say they're making crop circles, and there are lots of people who claim to have made lots of them. And in which case, if you believe them, then large numbers of the pictures you're looking at these days are all being done by people. I left the subject in around 1992 when the hoaxing issue sort of started to take it over, or in my opinion, it was starting to take it over. And things have really changed since then. Prior to 1992, when I was running the database at the time, we'd get reports coming in of single circles in corners of fields. I remember taking a flight with Busty Taylor and flying down to Winchester from Wiltshire, and there were just circles everywhere. There were little grape shots in the corners of fields. It looked like someone had picked up a paintbrush and flicked it over the British landscape. And it was a very different experience, I think, in those days, where I felt very secure and safe in those days, that there was a very small amount of hoaxing going on. By a few years later, you were getting 1 or 2 formations a week appearing only. Numbers had gone right down. They were huge kind of set pieces. They seemed to appear on a Friday night. And I must say I became very cynical myself. But the subject itself had changed. Most circles appearing were very, very complicated, very elaborate things. And I think it's an engineering question. The engineering question is purely, is it possible for a group of highly organised people, let's say with infrared laser rangefinders and all the kit you could imagine, really relatively good surveyors with good kit, to lay out one of these things in what's effectively only 5 hours of darkness in a British summer? If the answer to that is yes, then yes, these things could be being hoaxed. If the answer to that is actually, we've looked at it and we've asked the best that's out there to try and reproduce this sort of thing in 5 hours of light and they haven't been able to, then you've got to sort of start to ask yourselves whether they're lying to you, in which case why are they lying. And in some ways it doesn't really make enormous amount of difference to me anyway. If something's beautiful and it's something's very, very beautiful and you can learn something from it, then great. Then look at it, love it, get what you can out of it, and move on to the next thing. It's in some ways the question of authorship for me personally ceased to be really very important, because after I left the subject itself for me introduced me to the principles of geometry, which I still use and really find very, very interesting. And they also introduced me to the principles of harmony and how music fits together. And the synthesis of the two, which was done in some of the early crop circles, is really unique and interesting. So I'm really grateful and will always be grateful to the crop circles for kind of setting me on my way in my studies of harmony and geometry, and also being so innovative and creative and playful with those subjects, which actually up to that point had been quite classical and staid and a little bit fusty. So there was a playfulness and inventiveness around it that they brought to it, the circles, and still bring to it, I think, which is to be celebrated, whoever or whatever is behind them. So I think the question of authorship can be a tangent, but at the same time, if there is something supernatural occurring, well, not supernatural, but sort of beyond what this word supernatural is a very difficult word, I think. Great.
Sounds so great. You're doing really good.
Is that okay? Good.
I meant to remind you that you might have a phone that you want.
Does that thing get heavy?
Hun, can you get me some more milk?
I was doing this.
Yeah.
Very, very, very much.
5 minutes, it'd be hell.
Really?
But since I'm just kind of...
Cameras are rolling.
Okay. So going back to the last question, hoaxes. Does it seem improbable that they would have such particular, specific knowledge of geometry and some of these lesser known features of geometrical relationships?
I think any hoaxer coming to crop circles, some interesting things are going to happen for them. The first thing that's going to happen is they're going to spend a lot of time out in the countryside, which is great. Second thing that's going to happen is that they're going to pull a good one off. They're going to have to learn a lot about geometry, which is great as well. If they're going to spend a lot of time in the countryside doing geometry, well, that's exactly the same sort of thing that a lot of the people that were studying sacred geometry in workshops out in the countryside are probably doing as well. So in fact, everyone's studying the same subjects at the same time, which has got to be quite a good thing. I think there's another really important thing about crop circles, is that they are essentially beautiful, beautiful works of art with no ego behind them. There's no one claiming responsibility for them in great numbers. No one's making money out of them, certainly not the artists themselves. They're largely environmentally friendly. No, they're not using chemicals to make them. The distribution of the art is enormous. It's huge, has global reach. I can't think of a single British modern artist at the moment. Probably the most famous one we've got is whatever he's called, the Dead Cows. Probably the most famous British modern artist at the moment is Damien Hirst. He makes millions out of cutting cows in half and suspending them in formaldehyde. But if you showed one of his works of art to someone, let's say on an Italian bus or on a Russian subway or something, they're not going to know who he is. They're not even going to recognise his art. If you showed a picture of a well-known crop circle to, someone in Mexico City or something, they think, oh, it's a crop circle. They know what it is. So the reach of this phenomenon, just on an arts basis or on a marketing basis, without any marketing team, without any money behind it, has been absolutely phenomenal. I think that is often overlooked, that it's staggeringly successful penetration of sacred geometry into the common mass global psyche, without any attempt to do it on what seems to be an actual attempt to do it. It's succeeded. So it's I find that very interesting.
You lead me into the Banksy question. These guys remind me of the countryside Banksy.
They are.
Because there's an element of Joker there as well. Could you talk about that a little bit?
Well, it's the mercurial. It is the Joker. There is a sort of trickster element. I think it was Patrick Harper who first identified the basic energy behind the crop circles as being mercurius, or a mercurial communication. He identified the hallmarks of a mercurial communication as being essentially trickster-like. Hermes always has a trickster element in almost all traditions. Hermes is the messenger of the gods, so he's communicating some sort of divine message, often using sacred geometry, of which he's also patron of, and in some sort of common language, which crop circles are also doing. So there's a trickster element, but again, just to focus on the trickster element, not see the larger picture behind it, what it actually might be doing. I think it's a very, very, very rewarding subject to study in the period you do it. I mean, I studied it for about 3 or 4 years, got an enormous amount out of it, and have moved on. And I think for anybody who studies it, it's massively rewarding. I don't think you necessarily want to get stuck on it. John Michel used the allegory of Nebuchadnezzar's feast, which was a wonderful way of looking at it. He said that if you think of Nebuchadnezzar's feast, when the writing appears on the wall, there's always going to be some people there that kind of read the writing, and there's going to be some people that go, "How was that done?" And then there's going to be a third group of people who go, "Do it again." And you've got to work out which one of those 3 groups you want to be in. You just excited by it? You puzzled by how it's getting there? Does that matter to you, or do you want to read the writing? And I think reading and writing was obviously the original intention, and anything else is to be a little bit taken off to one side by something that could be much more important to you.
Good stuff. Getting back into the we're getting into the golden mean a little bit here, but
Yeah.
nature has a language that can be expressed mathematically, and we're seeing this language expressed in some of the crop circles. Would you agree, and can you comment further on that?
Yeah.
Sorry, hold on 1 second.
No.
Sorry,
We're good.
do you want to rephrase the question?
No, it's fine. I can do that.
Give me a message.
Yeah, nature does have a language, and it uses all sorts of different things in its language. The common language of all of nature seems to be number. Traditionally, numbers the way that the sciences boil everything down and take it apart and understand it. And the numbers of nature are depends which bit of nature you're looking at. If you're looking at the atoms or molecules or the all sorts of other bits and bobs, shapes of crystals and things like that. Then you get different answers. But if you're referring to the numbers of phyllotaxis, let's say the way plants grow, or the shapes of, I need to pause actually for a moment. I'm just pausing in a way. Hang on a sec. I think it's true. I'm saying rather a lot. Okay. It's a very big question, and just need to think about it momentarily.
Let's narrow it down to plants.
Okay.
To phyllotaxy.
Yeah. Okay. Yeah. I don't want to get. So what? Do you want to ask me? Start again. Ask me the question again.
Yeah,
I'll see if I can do better second time around. Okay.
Nature, let's say plant life,
Yeah.
has a certain mathematical language that it expresses itself through, or that is symbolic of its expression. Can you talk to us about how the crop circles have reflected this geometry in plants, how they grow, how they expand?
That's a very good question. The real difference between the plant kingdom and the mineral kingdom is the golden section. The golden section is pretty prevalent in all living things, in plant life, and almost to a lesser extent, funnily enough, in animals as well. Lots of different attempts have been made to apply the golden section to animals. The place you really see the golden section is in the way plants grow, particularly in the way that plants use the Fibonacci numbers. We'll talk about that again in a moment. But the mineral world primarily is using root 2's root 3 functions and tetrahedral arrays, octahedral arrays, and all the rest of it, which are all very interesting and all the rest of it. But the golden section is really the thing that identifies plant life. And crop circles are appearing in the plant life. And crop circles are, that's my mobile phone, which sounds like an elephant.
Which has nothing to do with root 2.
I'm very sorry about that.
No, we're at top of phylotaxis
Yeah.
again, yeah, and how crop circles seem to be speaking the same language.
Yeah. Well, I can only talk about my own intellectual journey in this subject, really. Let's just take 5 and 8, the numbers 5 and 8. The relationship between 5 and 8 was first brought to my attention through crop circles, because the circle makers were using 5 and 8-fold geometry a lot, and the marriage of the two numbers in really, really interesting ways. It was only a few years later, when I was in fact working with Professor Scott Olson in Florida on his book on the golden section, that I began to get to grips with phyllotaxis. And phyllotaxis is fascinating. You go out in the spring and pick a stem of pussy willow or something, and you count the number of buds on it. You count 13 buds. You'll find that you've gone round the stem 5 times. So it's done 13 buds in 5 rotations. That 13th bud lines up absolutely exactly with the first one. You need to actually do it to see it. If you pick an artichoke, we were counting artichokes. I mean, it's a little bit difficult at home because everything that comes into the house, I'm counting the spirals on it. But nature doesn't use 6s. I mean, you get a 6 in a flower, but if you count the number of spirals on a cactus or something, you won't get a 6. It's always doing 5, 8, 13. In some of the more complicated flowers, it'll go up to 21. The higher numbers, 55. Sometimes 144 if you're really lucky. But the Fibonacci numbers are the ones that nature uses 98% of the time. The Lucas numbers are also used, which are another set closely related to the Fibonacci series. But this 5, 8, 13 is really, really interesting, because most things that you see or you bring into your house or your plants, if you count the spirals on them, are 5, 8, and 13. The 5, 8, as I say, was first brought to my attention by crop circles. That just happened to be my own personal way in. There's lots of other people get other ways into it. And of course, by then I was already doing my work on the solar system. It's well known fact that Venus draws a pentagram around Earth every 8 years, which is very, very beautiful. So our closest neighbour is knocking out 5 in space to 8 in time, and 8 years on Earth are 13 years for Venus. So Venus goes around the Sun 13 times for every 8 times that Earth goes round, during which time she's drawn a pentagram. So our closest neighbour in space is drawing the numbers 5, 8, and 13. And all the plants on Earth are also doing 5, 8, and 13. Nobody ever tells you this. It's a very, very simple fact. Should be sort of introduced to children probably about the age of 5 so they can take more delight in nature. But for some bizarre reason, because it's not well understood, and it really isn't well understood, it's not taught. And particularly it's not taught that it's going on in space as well. In some ways they don't really want to talk about it. Don't want to talk about it because it's not well understood. And because it's slightly spooky, that what's going on up above us is also what's going on down here. So it's this slightly spooky set of relationship in numbers that also goes on in crop circles. Now, crop circles really is a very difficult thing to talk about sensibly without sounding like you're a complete lunatic, because they are very odd things. And of course, most people just default to the, they're being done by people, so therefore there's nothing very odd about them at all. And you can't really have looked at it very carefully. You've been taken in if you think there's anything odd going on. But you can put crop circles completely to one side and just say there's something very odd going on anyway with what's going on in the heavens and what's going on Earth, just by looking at those numbers. So that's just a little thing on phyllotaxis.
While we're on the subject of difficult questions, why do you think that is? Why do you think we have this hermetic principle as above, so below? Can you, comment on that?
Why? God, give me 10 secs.
Yeah.
I don't think I really want to go there, to be honest. I don't think I want to get into sort of guru stuff. Let me have a go in a moment. Try me again in half an hour. I'm sort of just getting a bit nervous for some reason.
Yeah.
Okay.
So,
I mean, yeah, I've got ideas, but they're. I think I can't really. I could do it over dinner late with a bottle of wine. It's harder on camera. Yeah.
Okay. So, getting back to, we noticed when we're in crop circles.
Yeah.
We don't. Well, I don't have a trained eye, but the ones that we feel there's a strong possibility they're hoaxed.
Yeah.
Don't seem to display the same in-depth understanding of geometry, and it's almost as if there's an aesthetic that's missing there, like the golden proportions aren't there. Can you talk about that a little bit? Do you think there's anything there that perhaps would differentiate a hoax from a real circle in terms of the geometry being used and that general aesthetic, like you said, walking through a gallery?
Mm. I think different people are going to like different crop circles for different reasons, and dislike other ones for different reasons. But to put limits on what a real crop circle is based on its design probably doesn't hold water. I mean, when one's talking about a genuine crop circle, one's tending to sort of think that it's been made not by humans. If you then think that a crop circle not made by humans needs to accord to the laws of some sort of geometrical principles or all the rest of it, and I don't think I'd agree with that. There are some interesting things, and Terence Meaden's work, early work on crop circles not being circular, particularly ones on slopes, is very interesting. He discovered that crop circles looked circular when viewed from above, but on a slope they're often oval or ellipses, as if something coming straight down had impacted on the ground, left a marking, and on a slope it would leave an ellipsoid or oval marking. And he did a lot of work on that and showed that their major axes of these ellipses weren't almost always pointing downhill, the minor axes pointing across the hill, which would sort of accord with what he thought at that time. It was in the plasma vortex era of thinking around crop circles, that they were caused by charged bodies of air or plasmas, which are localized. I'm not really up on the science, but sort of localized, positively charged, ionized sort of areas of air, a bit like a bubble, if you like, a bubble of electrified air within air, and that they were impacting on the ground. So there was some sort of actual real. He was interested in some sort of real way of differentiating hoax crop circles from real circles using those kind of principles. But whether, if you are, I suppose really what one's interested in is the paintbrush. If there is a real crop circle phenomenon, then there is a real paintbrush somewhere, and what that real paintbrush is really interesting. If there are limits on that paintbrush, then that's also really interesting. If that paintbrush, for instance, can only paint in harmonic or geometric ways, then that's very lovely. But the story of the crop circles generally all the way through has been to confound any limits put on it pretty much immediately that limits have been put on it, which then it does accord with its kind of basic mercurial character. So it always keeps everyone guessing, and plays with expectations.
I'm going to go on now to if you look at the Greeks, you look at Pythagoras, and you look at Plato, and even the builders of the Parthenon, you see the same optical illusions that we're seeing in crop circles to some degree. How do you think there's a connection there? That this you mentioned how the knowledge will pop up periodically and just stay alive in our consciousness. Is it possible that the Greeks knew something that we have lost that is now being reintroduced through crop circles? In terms of proportion and the harmony of the spheres.
I don't personally think the crop circles are introducing anything particularly new. They are playing with the perennial tradition. They're playing with geometry. They're playing with number. They're playing with harmony. Those are the same subjects that the Greeks were studying. The Greeks were studying them in a much more formal way. We do have extra mathematical tools these days that we can throw at things like fractals, fractal geometry, fractal mathematics. The Greeks don't seem to have been aware of that particularly. And also the Greeks were only dealing with rational numbers, so they weren't allowing for full decimals and expressions of pi and things like that, number e, things like that. And crop circles do seem to be playing with the full gamut of modern mathematics. So there is an extent to which they are being very, very creative and taking the Greek sciences way beyond where the Greeks understood them. But again, it's got a very small audience because the number of people looking at crop circles in that way is tiny. Nick Kollerstrom's done a lot of very good work on the mathematics of crop circles and the mathematics of geometry of crop circles. showing that they solve mathematical theorems. And Gerald Hawkins before him did much the same thing. In fact, Nick carried on, I think, with Gerald's work. And there are some really interesting things going on there. But it's not really my field, I'm afraid.
Yeah. Let's get into your field then.
Well, I don't know what my field is, but anyway, you're kind of going to get that.
Go ahead.
Okay.
Ask your question.
Getting into more what you cover in your little book of coincidences, can you talk to us about how surprised you were when you started looking at this raw data and these orbital patterns, and you noticed in the mean orbits these very direct correlations and these ratios?
Absolutely. It remains very surprising and strange fact to me that the primary proportions I identified in crop circles in my early work, which were the proportions defined by the pentagram particularly, and the octagram, very simple shapes, and there was one other one that cropped up all the time in lots and lots of crop circles, which was two nested pentagons. And I just simply called it two nested pentagons. You draw a pentagon, you put another pentagon inside it, and that creates a band, if you like, an inner and outer band. That proportion occurs in many, many crop circles, or did in many of the early crop circles that I was studying. And it also turned out that was the most common proportion in the inner part of the solar system, as it was the proportion created by pentagram and the octagram as well. So it was very, very odd. It was very, very odd to stumble on that fact, and to this day I'm sort of bemused, amused, confused as to what was really going on, which I think is really the experience of most people when they come to crop circles. I think you can divide the world of croppies into two. There are people who have had direct experience of very, very odd and strange things, and they happen to you when they happen. They don't happen to someone else. Hearing a story as though it's happened to someone else is completely different to something very, very strange and inexplicable happening to yourself. When very strange and inexplicable things happen to yourself, in respect to crop circles, they don't leave you, they don't go away, and you can't really communicate the strangeness of it to other people. The hoaxers will think that you're the victim of a self-induced state of perplexity as a result of one of their pranks. But I think it's much, much more complicated than that, what's actually going on.
Do you have any experiences like that?
I'll have to delve into my memory and try to think of one. I've had lots of very odd experiences. I can relate to experiences that happen to other people. I mean, some of the ones that for me, I used to have I had a dream. One night I had a dream, and in my dream I had a picture of Silbury Hill, and in the corner of it, as those watching on television, there was a little calendar flipping down with numbers, and then it stopped on a particular day. I think it was 26th of July or something. I may be completely wrong. And I thought, I wonder if there's going to be a crop circle that night at Silbury Hill. So with 2-3 friends, we went and climbed up Silbury Hill, got to the top, bedded down for the night. Not before we'd surprised a squaddy, actually, a squaddy up there who had his gun and telescopic sights and all the rest of it. He looked at us absolutely amazed as we stormed up the hill, saying, "What are you doing here?" And we said, "What are you doing here?" He disappeared. And then there was another guy up there. This was interesting, from Alaska, and he'd had a dream that there'd be a crop circle at Silbury Hill that night. And so we talked to him. Of course, in the crappie world, things like this are not unusual, and you tend to sort of take them in your stride. And sure enough, as dawn broke, there was this vast great crop circle in the field opposite Silbury Hill, which was immediately then disturbed by a very large army helicopter hanging over it, with people leaning out with cameras. And we ran down the hill and ran in there. Unfortunately, it was harvested before lunchtime. That's just it's one of many examples of strange things. And of course, the geometry on that circle was the same geometry as the geometry I was already studying but hadn't published at the time. So you're just left puzzled by it all, with the sense that there are odd things going on, that there are maybe some people out there who are slightly more aware of what those odd things are, but probably don't know much about it either. In fact, the people I talked to, Ralph Noyes, who I used to talk to a bit, he's now died. He used to be involved with the Centre for Crop Circle Studies and was also one of the people that investigated UFOs for the Army a lot. I do remember talking to him just before I left the CCCS and asking him about it, sort of straight, as I never had, sort of man to man. "Come on, Ralph," I said, what is it? You've been studying this for years. You've got access to all the army stuff and all the rest of it. You must have some idea. And he just leant forward and he said, John, you're not going to believe me. He said, but we don't know what it is. It's been playing with us for years. Seems to have a sense of humour. It's intelligent. Mucks around with our pilots. Mucks around with the guys on the ground. We have absolutely no idea what it is. And left it at that. And I believed him. I don't think they do know what it is. I think maybe some people might do, and a lot of people think they do and are hiding something, but that's as close as I ever got to an official explanation from someone that really should have known. But as an individual researching these subjects, you can get very close to it if you engage with it and act and engage with it sort of at a point of view that you actually imagine that you're dealing with something intelligent and deal with it as though it's intelligent, as though it can hear you and respond to you, then you'll find it does. And if you ask questions of it, you can find that they get answered. Once you've got your questions, you can go on and get on with the rest of your life again. And I think it works like that. People come to it, get something from it, and go away again. Quite what that intelligence is, whether it's earthbound or comes from somewhere else, I've absolutely no idea. And when I want to know, I'll go back and ask them again, I suppose. Yeah.
Getting back to Little Book of Coincidences, the one thing I noticed when I opened up the back and I saw these wonderful relationships, orbital relationships of
Yes.
planets to each other, those crop circles to me. I mean, I've seen some of these shapes I've seen in the fields.
Yeah.
Could it be that they're describing orbital paths to us and that these relationships, or, I mean, maybe that's going too far, but there's definitely a correlation, isn't there, between these orbital relationships and
Yeah.
crop circles?
Maybe include harmonic patterns.
Yeah. Because those are harmonic patterns.
Yeah.
I think to say that crop circles are pictures of orbits is to slightly miss the point, because if orbits themselves, as increasingly seems to be the case in the study of some of these the new solar systems being discovered and all the rest of it, a lot of those seem to be locked into orbital resonances as well. So you've got orbital resonances really seem to be everywhere. They seem to be the rule. So harmony seems to be the rule. The whole universe seems to be full of orbits in harmony, actually, and I'm sure geometry too. And the marriage of geometry and harmony is one of the most difficult things to achieve. That's number in space and number in time. They're very difficult things to bring together because of the way that... What was that? I don't know.
That's a bit spooky.
Yeah, probably a moth or something. Anyway, let's go back.
Restate
Yeah,
that,
let's restate that.
Restate
Um,
that. Was the book open for a reason? Or?
No.
Okay.
uh,
It's just distracting every once in a while.
Okay, all right. Sorry. Yeah. So
yeah.
these shapes,
Mm.
orbital patterns,
Yeah.
harmonics.
It shouldn't be surprising that that harmony seems to be a rule in the universe. Well, I did it better last time. Try and go back to where I was.
We can.
Yeah, okay, you connect to. I'll go back to.
If you could start over, I think it would be best.
Well,
In the very
it's
beginning
never-
of last time, you had the book open and you were looking at it for quite a while.
yeah.
And I could tell your eyesight was much
Sorry.
lower.
Oh, that was it. So that then wasn't working anyway. Okay.
That's my fault.
No.
Right. I don't think it should be surprising that harmony seems to be a rule in the solar system, or in the solar systems in general. Okay, third attempt. Cut. Start. Wipe. Restart.
You said
It-
it's
the-
missing the point.
Yeah, so that was the response to the question. It's very interesting in a lot of the new solar systems that are being discovered at the moment, and they're discovering them pretty much one a week at the moment, some of them with 3 planets orbiting stars. And of course, they tend to be these very big planets at the moment, so we're not seeing the full picture of new solar systems. But what seems to be coming through in all the new data is that orbital resonances seem to be everywhere. So the entire universe seems to be full of things spinning around planets spinning around stars, with those planets locked into orbital resonances. And orbital resonances are based on harmony. That's number in time, simple fractional relationships between periods and of orbits, and geometrical relationships between planets as well. There's not enough data yet on other solar systems to be able to show that, or disprove that they are existing or not existing. But it wouldn't be at all surprising if they do exist, because we know that there are geometrical relationships in our own solar system. but to then say that crop circles are pictures of those orbits is to miss the point, I think, because the point really is the universality of harmony and of geometry. Geometry and harmony seem to be everywhere. They're the principles. Number likes doing simple things. If it can do it simply, it will. If nature can do it simply, it will. If it can do something that seems to be complicated simply, it will. Phyllotaxis being the best example, where you get surrounded by this what looks to be extraordinary complexity in nature. In fact, just using just these very simple numbers of 5, 8, 13, all the rest of it. So nature likes to use these basic principles. And if crop circles are also using those principles, then that's the point, is that the crop circles are just using these same principles, not necessarily that one is a picture of the other, I think. Very good.
Okay. So,
I can jump in.
in a Cartesian mechanistic world,
Yeah.
Universe, which is the one we've been told
Yes.
exists,
Yes.
isn't it a bit odd to find that harmony and number are so closely related and expressed by these planetary bodies? It's not at all what we would think to find in, like, Dawkins' universe, for instance.
It is very interesting that we've come to that. You only have to go back 400 years, and everyone would assume that was what the universe was like. So the harmony of the spheres was a sort of rule. I mean, everyone assumed that the universe was full of harmony, and everyone was looking for it. Kepler made his discoveries of the elliptical orbits and relationships in the orbits because he was looking for harmony in geometry. So he was assuming it. It's only really when you get to the modern sciences now that where nobody really, your average scientist today couldn't really tell you about the syntonic comma, let's say, which is a very simple fractional relationship that pops out of the difference between the minor third and the major third. That you end up with a world where you've got scientists fundamentally unschooled in mathematics of music, let's say, who therefore write off the fact that this is relevant when they're looking at their orbits. I don't want to do anything they're doing down, because everything they're doing is absolutely brilliant. There's just a few big and very ancient black holes that should be being studied, and I would suggest it'd be much better that people were taught them as well at quite an early age. They're very simple things to do. Geometry is very well taught in school, to a certain extent, but for some reason harmony doesn't seem to be, and even a lot of musicians that study music don't really study the mathematics of harmony. It is just fractions. It's very easy. It really is very easy, whatever anyone says. And putting the two things together is what seems to be going on around Earth. I just can't really see the difficulty with it. What's left with is a cultural difficulty with it for some reason. I can't quite understand what that reason is, personally. Why are we not taught about the 5/8 Venus pattern from a very young age, and how beautiful it is and how much it looks like a flower? Why don't little girls learn that when they're 5? It might get them more interested in maths. I'm just puzzled by it. I don't know why it's not taught. I suppose it isn't taught because it's not understood, and that's the bottom line at the moment. Things need to be understood before they're science, and once they're understood and become part of the body of science, then it's okay for them to be taught. Whereas speculative sort of meanderings around these very ancient, sacred, sort of delicious kind of subjects that form the basis of aesthetics and music are somehow out of bounds still, and that is a cultural problem, not a problem for science, really.
See. Okay. What's the other question?
Yeah, I was just going to jump in a couple of points, but again, just keep your eyes on Charlie, even though it's a question for me.
Okay.
I was just going to ask if there's a universal language, like a cosmic language, would geometry be a logical choice?
I think that's a very good question. It's an excellent question. The universal languages any universal language must be a language that's devoid of culture, and to a certain extent something. Start again. Geometry would be an excellent universal language. Any three-dimensional life form anywhere in the universe is going to have pretty much the same understanding of a square, of a pentagon, a hexagon. It's going to know those shapes. It's going to recognize them, and be able to play with them in much the same way that we can. The fact that pentagons don't really work very well on the plane, and you have to move into 3 dimensions before they wrap together into a dodecahedron, is going to be something that every semi-sentient, clever, three-dimensional life form anywhere in the universe is going to agree with you about. I think a more interesting approach would be music, in a funny way. Music is more of a universal language than geometry, you could argue, because you can do things with it immediately. So the ability of two musicians from different species anywhere in the universe, the likelihood that they could pick up their respective instruments, whatever they were, and blow them, and they're going to get the same sort of fifths and fourths and thirds, I'd say is more likely than they're going to have fun playing with hexagons and pentagons. So music's the most likely contender. Carl Sagan always said very much the same. Geometry's more intellectual, music is more something you're going to use as a communications device, probably. Yeah, I mean, it depends what you're trying to communicate, but music of the two, music would get my vote. Everything else would have to be semantic and syntactic, have syntax, and so then you get into proper language, in which case you need a translator. But for music and geometry, you don't need a translator, and they would work as universal languages.
You're giving me back into Pythagoras here. Pythagoras was once quoted, even though we don't even know he was an individual, but the Pythagorean kind of mindset, as saying, someone asked him to explain God, and he struck a bronze urn, and he said, "That is the sound of God." Extrapolating that, is it? I mean, not to get into creator stuff, but we really are kind of leading there. When you look at the solar system, does it seem to be complete, like an octave? Obviously, there's more than 7 planets, but it has this interplay of resonances to kind of form a whole, the symphony of the spheres, if you will. Have you found that in your work at all? Does it seem to be part of a symphonic movement, like almost an orchestra, where each planetary body plays a certain role?
Well, that was certainly Kepler's vision. For me, understanding the geometry of the solar system and its harmony, being able to sort of hear its harmonies, Mars and Venus are Earth's two neighbours, and for every 4 times that Venus passes behind the Sun, Mars passes behind the Sun 3 times. You've got 3 to 4 with our two neighbours, which is very nice. So you could experience that as a rhythm, or you can experience it as the musical fourth. So our two neighbours are knocking out this beautiful relationship. And for me, the understanding the geometry and the harmony of the solar system is simply a way to make home intelligible. It means you get to know your home. I can draw the solar system on a piece of paper in 10 minutes with a ruler and compass. I can close my eyes and visualize accurately all of the orbits of the solar system, not through any great trick, other than simply the fact that I know how to proportion them. I know how to proportion with tools and devices and pentagons and all the rest of it. And I think if you are in tune with your home and you can picture it, then you're in it. And if you're in it, you're part of it. And so it helps you to be more part of it. And if you're more part of it, hopefully you might end up having a better idea one Friday afternoon. And for me, that's what it's really about.
Okay.
Yeah, I was just gonna. Can you talk a little bit more about the connection between music and geometry? Can you talk a little bit about? I mean, I don't know. It's a little bit beyond me, but maybe you have some research or some knowledge about how those are connected. Because
it is the most difficult thing. My PhD in it got turned down because they couldn't find anyone to supervise it.
Well, just some thoughts. Maybe even if it's provable, just some idea.
Okay, let me think. Music and geometry. I can tell you what they are. Maybe the easiest way of doing it. The best way of getting your head around it is to look at it in the medieval way, the way it was taught in the medieval period, which goes back to the Aristotelian way of looking at it, which is to base these subjects in terms of the liberal arts. In the liberal arts, you've got liberal arts are divided down the middle into a group of 4 and a group of 3. The 3 liberal arts which deal with communication are logic, rhetoric, and grammar, and they deals with how to win people over to your point of view. Have a good argument, deliver it well, and make it hang together logically. Barack Obama is a really good example of someone who's well trained in the trivium, delivers very, very good speeches. The other 4, and the trivium is still widely taught actually of the liberal arts. The 3 liberal arts dealing with language is still very widely taught, particularly in America, particularly to lawyers. But the 4 liberal arts that deal with number aren't so widely taught. They are increasingly well taught, but mostly outside the academic and professional environment. And they are number theory specifically, the dealings of how numbers actually work and relate to one another just as numbers. Then you have number in space, which is geometry, the way number works in space. And then you have number in time, which is harmony. And then you have number in space and time, which is study of cosmology, or the natural world, as Aristotle extended it. So you can see sandwiched in the middle of that, you've got these two subjects, music and geometry, the study of number in space and the study of number in time. Now it would be very, very nice if they both worked in such a way that they fitted together, but those two subjects really don't fit together very well. The way number behaves in space is really very different to the way it behaves in time. I could start going into some examples for you, but you just have to take my word for it. They are very different. The problems you get in geometry, let's take sevenfold, take the heptagon, the way that sevens don't fit together on the plane, the way that sevens just don't fit together and are rather problematic in plane geometry is quite similar to the way, let's say, that octaves and fifths don't really fit together in music. If you were on a piano and you go up 7 octaves, you've gone up 12 fifths. They agree, but if you want to hear that as pure harmony, it doesn't work, and you end up with something called the Pythagorean comma. Fifths and octaves just don't add up. In fact, nothing adds up in music at all. So things go wrong pretty quickly in music, and you end up having to fudge and pull and stretch and play with your harmonies as though they're putty, just to actually end up with a usable scale. And so music's a very different kettle of fish to geometry, where squares and triangles can fit together, hexagons fit together with squares, even octagons fit together with squares, and you don't get gaps between your tilings. In music, the same thing doesn't happen at all. Also, different numbers have very different roles in geometry and in music, and the two subjects are really they're best described as sort of two sides of the same coin, but they are very different sides of the same coin.
Can we move into?
I don't know if that was any help.
No, it
Right,
was,
okay.
actually.
Right.
Moving into cymatics for
Cymatics, yeah, great.
The way that sound creates form, seemingly. You can put sand on a speaker, or you can use water. And certain frequency seems to generate certain form. Could that be what we're seeing in the universe in general? Could it be a pervasive sound that literally gives form to matter, to 3 space? Comment on that, or is that just?
Yeah, no, I mean it does seem to be a principle. I mean, it's resonance. Cymatics is really the visual, visual displays of resonance, and cymatic forms on a plate occur when you've got a frequency that's normally some whole number fraction of the length of the edge of the plate, and that's when you get your stationary points to produce all the patterns. So it's very, very similar idea to some understanding. Let's say a visual expression of cymatics in the solar system would be the gaps in Saturn's rings. The gaps in Saturn's rings are all entirely cymatically cleared, if you like, by Saturn's moons. All of the gaps in Saturn's rings are cleared where you've got a distance from Saturn that's a harmonic resonance of one or other of the moons. So that's just how they form. It's well known. So yeah, it is operational all the time, but it's very slowed down because those moons, you don't think of those moons as actually playing a note because they're going so incredibly slowly compared to an audible note that we can't hear the note. But if you sped it all up, you'd hear it all as a set of pings and nice harmonics and all the rest of it, and those little black gaps would be cleared by those frequencies.
That's incredible to me.
Yeah, that's well understood.
Can you talk about Little Book of Coincidence? Can you just talk about your thesis for the book, what connects all the pages, and maybe like you're explaining it to a 5th grader?
Okay.
Which is kind of what I am intellectually. So
Right.
Go for it.
Right. Yeah. When I stopped doing crop circles, it was really because I wanted to find out more about the geometry and harmony of the solar system, and the work. I then went and studied under Keith Critchlow at the Prince of Wales's Institute of Architecture and did a master's there for 2 years, pretty exhaustively looking at the solar system in terms of as though it was a sort of resonant or geometric shape, trying to discover if it had geometric relationships between planetary orbits and harmonic relationships. And I published a large list of all the relationships I could find, graded in terms of their accuracy, and eventually decided that was far too complicated, and I just cherry picked all my best findings, which is a very unscientific thing to do, and came up with my book, The Little Book of Coincidence, which is not a scientific book, but it's really a book for artists and people that want to be able to visualize the solar system or draw it, or for people that want to, as they're wandering along and look at a pattern on a wall, think, oh look, there's a picture of Jupiter and Saturn's orbits, because all around us, all the time, in windows, on car tires, on everywhere, are geometric shapes that we're looking at all the time that, little known to us, are actually also solving the planet's orbits. So I just wanted to bring that attention to the public and sort of make it more accessible, and also throw in a few sort of speculations as to sort of some of the peculiarities of it, and particularly the beauty of it. And for me, it's therapeutic, actually, because I think if you actually think that the solar system is a set of chaotic, random orbits, and that we're this sort of meaningless ball of, well, not meaningless, but we're living on this planet and it's rattling around space. That's one kind of world or cosmos to live in, but it's not actually accurate. Accurately, we're actually whizzing round the sun, and our closest neighbours are whizzing around us in incredibly beautiful and harmonic patterns that are being exactly played out in plants and flowers all around us as well. So I find it really therapeutic to know that that's the truth of what's going on, and you can't really be miserable or unhappy or depressed when you sort of get when you get the hang of it. I find it's a fundamentally transformative and happy thing to get your head around. So that's kind of why I did it. I wanted to try and communicate this very I found transformative vision of the solar system to a wider audience.
Okay.
Going along with your book of coincidence, do you think it's a mere coincidence that I looked through your pages in your book and a lot of the designs look like crop circles? Well, I want to get.
Yeah. There's a very deliberate correlation between in the book of coincidence and with crop circles for me. Because, I mean, I owe a great debt to crop circles, because crop circles were what got me going. Crop circles was my ABC of geometry, and actually it wasn't beyond being an ABC, because some of the things that crop circles taught me were really quite advanced bits of geometry that no one that I've ever met could have taught me, and yet they were very simple, as I was saying earlier, between the relationship between a 5 and the 8. And I'm always going to be grateful to whoever or whatever is behind the crop circles for bringing my attention to certain geometrical coincidences. And it was then an added bonus for me that those same geometrical coincidences happened to show up in the solar system and solve the planetary orbits. And it was an added tri-incidence, if you like, at the end, that those very same numbers happened to rule most plant growth on Earth. And there's more to come. I'm still working on other bits and bobs regarding those same proportions, and I keep finding them everywhere. And I'm sure I still will for years to come.
So thanks, Doug and Dave.
So thanks, Doug and Dave, indeed. Yeah.
This is my last question. Along those lines, my question would be, could the geometry in man-made circles be accidental?
That's a really good question.
Yeah, super.
Some people ask, could the geometry in man-made circles be accidental? It is a very good question. There are only a certain number of things you can do with a circle. If you keep a circle at a fixed length and you've got a piece of string and you're drawing circles, you will learn very quickly. Most children do. When you walk a circle around its perimeter, it produces the what's now called the flower of life, the 6-petaled flower design, and everybody discovers that independently. It's part of the universal language. One of these things that's going to be the same, understood in much the same way all over the universe. So yes. Hoaxers with no schooling in geometry can stumble independently on advanced geometric forms, or you could call them simple geometric forms, but you can also get quite quickly some advanced geometric forms as well. On the other hand, hiding golden sections in your designs, as was what was going on in particularly my era, which was 1991, and using those principles again and again does require a certain amount of self-conscious deliberate attention to detail that I doubt someone stumbling around in the middle of the night in 4 hours of darkness on a wet British evening without leaving muddy footprints all over the place could possibly pull off.
Great, that was fantastic. I've got to ask you this because you're kind of skirting around it.
Oh yeah.
So, what would you consider yourself, an evolutionist or a creationist? I mean,
Me personally?
Yeah, having studied all of this and seen all this coincidence,
Oh.
has it changed your view of perhaps the prime mover, let's say, or?
I don't know. I always used to talk to John Michel about this. My favourite writer at the moment is James Gardner, who's a West Coast complexity theorist. He's been writing 2 or 3 books about the anthropic principle, which is this conundrum in modern physics that the whole universe seems very weirdly or coincidentally life-friendly. And his solution to it, which I think is really novel and interesting, is that the universe bears all the hallmarks of a child, really. A child that has parents, in fact, or had a parent universe, because there's only 2 ways out of the problem. Either you have to say that this entire universe is one of millions of universes and just happens to be this way, where it's very, very, very life-friendly, or you say it's deliberate. Well, if you say it's deliberate that it's life-friendly, then you're also left with 2 possible problems. One is that it was created by some all-wise God who goes bing and makes it so, and the other one is that it had parents. And Gardner's the first person to really suggest this, that the parents kind of thesis, that the universe looks like itself, that these fundamental constants that make life very likely here seem to be some sort of cosmic DNA passed down from, so that the Big Bang, in his idea, the Big Bang kind of encodes the extreme likelihood for life in that moment. It throws out, everything gets set up in this particular extremely finely tuned balance, and makes life probable, likely, almost certain. And but I think everyone's got their own ideas about that. But I don't think crop circles particularly have changed my thinking about it. But they're certainly produced quite a few things you can throw into the cauldron, I think.
Right. So
Yeah.
you're talking about the metaverse idea, the idea that there was an original universe that gave birth to this one.
Yeah, I think that's what Gardner's theory really is, that if you look at so he's a cosmic evolutionary. He's developed a cosmic evolutionary theory, if you like, saying that it's not just things like us that evolve, but that the entire universe is evolving. Will continue to evolve. We'll continue to wake up, become sentient, become super clever, super intelligent, develop into things that we can't even dream of, and then we'll have children. Those children are going to be little Big Bangs, and they're going to carry with them all of the potentiality to turn into the oak tree that's our universe, if you like, and with its own acorns, which are us, kind of thing.
That's fantastic. Yeah.
Do you want to talk about Bode's law?
Bode's law.
Did you need to take
Yeah.
a break? Or are you doing?
Yeah, we could have a break.
Yeah.
It depends how much more you want to do. Yeah. Sun's come out. Let's have a break.
Just let us know, Ryan.
Yeah, whenever. Are you ready? Whenever you're ready.
So we're going.
Yes.
Yeah. Okay, John, I want to ask you about one of our closest neighbour that anyone can look up in the sky and see. It's a really close example, the moon, and the wonderful geometry that we find there, and how that relates to Da Vinci's Vitruvian Man. Can you talk about that a little bit, and the really weird ratios that we find there?
Yeah, the moon is the biggest puzzle of all, in many ways. It certainly puzzled our ancestors more than many things. I mean, Venus, as I've said before, is very easy to resolve. Even Mars actually resolves very, very nicely. Mercury's doing all sorts of interesting things, but the moon alone is just, the numbers involved with it are so difficult. Stonehenge has 29.5 stones in its outer ring. The half width one's still there. Everyone says it has 30 stones, but if you look, there's one that's half the width of all the others. So the builders of Stonehenge clearly knew that there were 29.5 days between full moons, and it's encoded there. The 19-year metonic cycle with the moon is also a common feature of early stone circles and everything. So if one thinks of man as a pattern-forming animal, trying to find patterns and understand the universe in terms of patterns, i.e. simplifications, then the moon's pretty much the hardest one to do. At the same time, it's actually the simplest in one very obvious way. That's really a useful thing to think about. It's really quite often, which is that the size of the moon in the sky is the same as the size of the sun, and those two bodies form this perfect balance of two principles, which is really very, very beautiful, very precise, and very, very thought-provoking, and very sort of can give you a nice warm feeling, rather than the sense that everything's all over the place. I think it was only in the late 1960s though that John Michel discovered something else that was very interesting about the moon. And he discovered that the moon, if the moon is size 3, then the Earth is size 11, and that the 3 to 11 themselves form the squaring of the circle. If you bring down the moon onto the Earth and placed it so that it was adjacent, and you put a square around the Earth, then the circle through the centre of the moon would have an equal perimeter to the square around the Earth, so that the moon and the Earth square the circle in their sizes, which is a geometrical trick, but it's still very interesting. And slightly even more strangely, that the mile still used in America and in England accords to that geometry, so that you've got the radius of the moon is 1080 miles, which is another sacred number. So Michel's work is very interesting because it synthesizes geometry, the astronomy, and the size of ancient bodies, but also hints at the fact that our ancestors knew some of these things, and they're encoded in measure as well, some of the ancient measures. And some of these ideas are really almost too difficult to wrap your head around. Who could possibly be measuring the radius of the moon accurately in antiquity? And yet the evidence seems to point to the fact that somehow this was being done. And the moon really is a very interesting beastie. Robin Heath's work is also very, very interesting. Robin's proven that most of the Sun-Moon Earth system in time can be boiled down to just the numbers 18, 19, and the golden section. So those are the only numbers you need. In fact, the only number you really need is 18 and the golden section, because the golden section takes all the values from 0.618 through 1 to 1.618 and 2.618. So, for example, the number of days in the year, very difficult number, 365.242, doesn't seem to really be a particularly easy number to get your head around. Turns out that that's 18.618 times 19.618, or 13 full moons is 20.618 squared. The Robbins work's very interesting as well because it's a rationalization, shows a hidden pattern involving the golden section that solves the timing of the Sun-Moon-Earth system to a really quite usable degree of accuracy. It wouldn't be usable for firing rockets into space or launching satellites or all the rest of it, but it's perfectly usable for most practical purposes, and very interesting. So these things keep on popping up. There are researchers out there still producing really interesting breakthroughs, I think, in this sort of area.
Great.
We are rolling again.
Okay. So a lot of the things we've been talking about, the geometry we find in circles in the solar system, you also find in stone circles and how they relate to one another. That's kind of a uniquely British phenomenon. Can you talk about that a little bit? Maybe the megalithic yard as well, if you feel like it.
Yeah, stone circles really are very interesting things. They're very early. The period of stone circle building in Europe is from around 2,500 BC through to about 500 BC, the later ones. Like the pyramids, where the biggest and most complicated one, the Great Pyramid, goes up right at the beginning, you've got the biggest and most complicated stone circles going up right at the beginning, Avebury and Stonehenge. And they aren't typical as stone circles go, but they do involve huge amounts of astronomy and geometry in their construction, very intelligently done. And you're left with this sense of a culture who we really know very, very little about. We know roughly bits and bobs of how they lived and where they lived and what they ate and some of the tools that they used. But in terms of the cultural apparatus that enabled them to sustain this huge architectural kind of endeavour for so many years, there's very, very little known. All we've got are the stones that are left, and we know from that we can derive just a couple of things. They were using geometry. They were very interested in where the sun and the moon rose, and they seem to be very interested in some of the cycles of the sun and the moon. And what one's left with stone circles is a strange sort of sense of a culture for whom the motions of the heavens were very, very important. And what they seem to be trying to do was to create spaces on the ground that were sort of reflections of what was going on in the heavens. There are other aspects too to stone circles that are really that pop up every now and then disappear. People don't really talk about them. There's some work by Ron Curtis up in the Outer Hebrides, which is one of the stone circles really far, far north in the Northern Isles off Britain, where there's a cluster of stone circles around that latitude. The reason possibly being it's because it's where the moon doesn't set every 18 and a half years on its cycle of deviations and things. But what I was going to say now. It's Ron Curtis's work. Ron Curtis's work is very, very interesting. What Ron's discovered up in the Outer Hebrides, where these stone circles are more or less intact, is that you've got these shapes of stone circles, different shapes that we know that they were using. They weren't just building circles. In fact, most of the time they didn't. Certainly in the early stages, they're building these ellipses, egg-shaped stone circles, flattened stone circles that look a little bit like eyeballs. And although some of the internal geometry of the stone circle will often line up to midsummer sunrise or extreme lunar alignments, what Ron's realised is that the circles themselves, the geometry of the circles themselves, actually point to other circles. So the circles are actually picking out other circles, most of them out of eyesight, over the hills and far away. So circles are all relating to circles geometrically. There's some new work by Howard Crowhurst in France as well. He's realised that the entire Karnak complex in France, which is a very huge megalithic complex, is largely based around 3, 4, 5 triangles and breakthroughs like that. It's very perplexing. You're left with this sort of huge, sort of perplexing question: why on earth go to all this bother? Why bother? Why build all of these things? And I don't really know that I can feel. Waffle. Waffle. Oh, squeeze calm.
Yeah.
Let me try and say something intelligent. Okay, I thought it was something. I think stone circles are a very good example of a something, like, let's say, crop circles, of a phenomenon, if you like, that you can look at, study, and all the rest of it. That the more you look at it, the less you feel you're really getting to grips with what's really going on. With crop circles, the more you dig at it, the stranger it gets often. And stone circles too really do raise more questions than they ask a lot of the time. And I'm still not quite aware of what I'm trying to say. Okay.
I like where you're going.
Right. One example of a very strange question that's thrown up by stone circles is Avebury's exact position on the Earth. If you take a GPS to the centre of Avebury stone circle, you will discover that you are precisely 1/7 of the way down from the pole, not just to within 100 feet, but to within 10 feet. The centre of Avebury is exactly 1/10 of the way down from the North Pole. If you want to go 1/7 of the way up from the equator, then you find yourself at Luxor, or in the old words, Thebes. So the ancients seem to be able to position themselves extremely, extremely accurately on the Earth, using a technology that we don't have any evidence for, although Robert Temple's recently discovered a lot of ancient lenses and thinks they might have had primitive theodolites. But even then it begs the question, how could you possibly position a temple to within a couple of feet at an exact parallel that you wanted to on the Earth? So there are questions raised by things like that. Was it technological? Were the ancients actually using technology as we would, as a modern engineer would, in sighting something, much like a crop circle kind of question? How is this being done? Or is there something else going on? Was it possible that there was in the ancient world, there was actually a perception, some sort of direct perception of energies, latitudes, harmonics, and things that we don't really have very much record of, and certainly no real modern parallels of? Some people do see things today, but it does fascinate me, the idea that there could well have been a period on the Earth, and it seems to me that this might have been what's going on, where people are much, much more in tune with where they are. You might imagine your kind of early native British person wandering across the landscape and suddenly seeing a great red band across the landscape, or a huge great blue pillar or something. I mean, these are experiences that people still have today, and a lot of people are having them. Then you might decide to build your temple there. It might happen that temple's actually, that blue pillar's been caused by an electromagnetic harmonic or something that the person's able to see. And then 2,000, 4,000 years later, we all sort of say, oh, they must have measured this. It might not have been they measured it at all. They might have been able to see it, they might have been able to hear it, they might have been able to sense the harmonics. But you're still left with all sorts of questions. Stone circles are still largely not understood and throw up more questions than they ask. Although the astronomy, I think, is more or less cracked, but some of the sighting and measuring isn't. Still don't quite know what I'm trying to say. I'm trying to get somewhere.
That was awesome.
What?
That
Is that any good?
It's good, yeah.
Yeah, I think Burke and Talbot's work was absolutely fantastic, and it's a real pity that more notice wasn't taken of it, and that it hasn't been reproduced since. Although the climate is much harder to do that kind of research in now because of the amount of hoaxing. But yeah, they discovered all sorts of changes in the crop, and they reproduced their findings again and again and again. Everything seemed to, as far as I'm aware from my, I mean, it's some time since I've been up with it, but everything seemed to point, I think, to some sort of microwave effect. Yeah, it's extremely interesting, and yeah.
Okay.
Right. Okay. I'm. Yeah. It's. I haven't had to fight very hard to get it out at all, personally. But it is why wasn't it already out there? Well, because no one had looked. That was. I do remember feeling when I was doing the work. This is a little bit strange that nobody. We've had all this data for 400 years since Kepler, but I've trawled through it all, and there really isn't very much. No one's really tried to look. I did find that a little bit odd that one could crack something so easily. So that was a bit strange. And then having looked and found it, why isn't it taken up? Well, I really don't know the answer to that, except that it go back to what I was saying earlier. That you're left with a sort of cultural thing. Either you've got people who aren't interested, or it seems too far out because we're all brought up in a world in which this sort of thing shouldn't be happening, or they can't really do the numbers at all. You do need to be able to do a small amount of numbers. So the number of people who even think numerically or mathematically is quite small, really compared. It really isn't vast. And of those people, most of them are probably not that interested. So I don't know. It's a sad thing. I wrote the book to sort of switch people on and kind of excite people that stumbled across it. That was its job. It wasn't designed to be a scientific book. It was just designed to be to deliver a sequence of eureka moments and sort of happy kind of wows. It's designed to deliver the wow feeling again and again and again. And to a certain extent, we've designed the whole series, the whole Wooden Book series, has been designed to do that. To deliver these small personal eureka moments where you suddenly sort of feel you're in good hands. You can trust the series. We can explain mathematics and music to you. We can explain the basic principles of geometry to you, how the universe works, how electrons work. Try and get the whole of the modern sciences across, but frame them in a magical, traditional, kind of frame. Yeah.
Yes.
Okay. But one of the things I've just been working on that's really another one of these things that's sort of unexpected and confirmatory in some way, and yet it's utterly strange and bizarre, is what are called rainbow angles. And I've been looking into this for a few years, and my work all suddenly came together about 5 days ago, I suppose, or a week ago. I couldn't sleep, and I suddenly realised, or I got the numbers out, that the angles of halos around the sun, do you know, sundogs we call them, where you get two little spots of rainbows to the left and the right of the sun, and then so the sun's there, you've got two little rainbow spots here and here, and then you also get sometimes, very rarely, get an outer halo as well. Well, the two spots that appear around the sun, so the first solar halo is what's called the 22-degree halo, although its brightest part actually appears just slightly outside that. So you've got these rainbow circle around the sun at 22.5 degrees. That's each way of the sun. And the outer halo is at 46 degrees. So the ice halos around the sun are at 22.5 and at 46 degrees. So I thought that's very interesting, because 22.5 degrees around the sun is where Mercury is, and 46 degrees is where Venus is. So it's a very, very strange fact, very odd coincidence that drawn in rainbows around the sun on a frosty evening is drawn for you absolutely to scale the orbit, the mean orbit of Mercury and the orbit of Venus. In fact, the Venus one's so accurate that the actual thickness of the rainbow band is the variation of Venus's orbit as seen from Earth, which is a very strange fact. There's no reason why it should be there. It's a bit like the moon and the Earth, moon and the sun and the moon being the same size. Absolutely no reason it should be there, but it is. So then I sort of thought, well, those are halos, ice halos, when you're looking at the sun. So what happens if we turn our back on the sun and look at an ordinary rainbow? Well, the middle line of an ordinary rainbow turns out that that's exactly what. Of course, we're now looking away from the sun, so the next planet out would be Mars. So you'd expect some relationship with Mars, and sure enough, you can't really see Mars' orbit because it's bigger than ours. So what you have to do is invert things and imagine you're standing on Mars, looking at the sun, and the size of a rainbow is exactly how big Earth's orbit looks from Mars. So all four inner planets are proportioned in light accurately by complete coincidence. And there's no reason for it. It doesn't have to be like that. It just sort of is. And I'm always amazed by these things. And this whole journey for me started with crop circles. And it just seems to never stop. Wherever you look, there are these extraordinary, beautiful things going on that science cannot explain, and which, with a small amount of thought, you can easily get your head around. It puts a big smile on your face for weeks. Right. Great. All right. Isn't that
Intimately same spread. I mean, how
Water,
does that
water light.
It's just like, what's going on? I mean, it's still sort of sinking in. It's just sort of.
It's like the
How is that
holographic
possible?
universe, almost.
Yes, it is sort of holographic. It's just.
Physicalised.
They're just windows, clues into another level of reality and science, of which we can't even guess at the moment. There are these little glimpses of another science. That's all I think it is, or another level of reality. And you can see it. Just the sun and the moon is the first glimpse that there's something going on. No reason for it, just odd. And then these things just build on one another, and you get more and more of them. You think, that's very beautiful, that's very harmonic, that's very balanced. How very odd. No reason for it. And you go right up to things like that rainbow thing, and it's just incredibly strange and beautiful and lovely. And that's all I can really say about it.
That's it. That's good.
Yeah.
That's me, guys. Unless you have more things you want to add. I mean,